Workplace 30, this is chapter 2. We're launching chapter 2. So we're going to look at 2.1 here in a second. The chapter 2 is entitled Limits to Measurement. So we're going to be talking about measurement, talking about conversions. You see in the picture here we have and this is from your workbook. You see we have a guy making a measurement, right? He's measuring a certain distance, looks like from the floor onto wooden studs in a framing situation. Now I actually spent a summer framing, just like this guy. And there's a lot of measurement has to take place, a lot of perpendicular, 90-degree square corners, and things have to be level and all that sort of stuff. But measurement is a huge, huge part of it. Actually, I had a bit of an incident with a nail gun, my first time actually using a nail gun. And I almost blew a hole with the nail gun. I almost blew a hole through the window on a multi-story building in Calgary. So so that was pretty fun. Although the guy I was working with, my boss, he thought, what have I gotten myself into hiring this guy? But anyways, so yeah, be careful around nail guns, okay? So just Anyways, so limits to measurement. So what are we going to talk about first? We're going to talk about in 2.1 accuracy and precision. Now these are two terms that are oftentimes used interchangeably by people, but they actually are a little bit different. If you've been in a science class, you've probably heard the difference between these two. Now, we'll work through the material here and start at square one. So what we're going to do first is review the SI system, the base system of measurements and conversions. So I talked with some of you before and didn't seem to have very good memories of this, but hopefully we'll use that metric staircase, and hopefully these conversions shouldn't be that bad. So SI system is the System International. The prefixes tell you the relationships between the numbers. So for example, if we have a base unit of a meter, a kilometer is, where is the kilo on here? Oh, here it is. Kilometer is 1,000 meters, or 1 meter is 1,000th of a kilometer. Now if we have a centimeter, right, 1 meter is 100 centimeters. So there's 100 centimeters in a meter stick. So here's a meter stick, and it starts at 1, and 1 meter goes all the way to 100. So that's a meter. It's 100 centimeters. So the prefixes that we're going to be studying are, decimeter, centimeter, millimeter, decameter, hectometer, and kilometer. So the prefixes there, the parts of the word at the beginning are the metric, the SI system. Okay, 1 kilometer. Now notice that it's a French system. Like the name is a French, it's System International, and it's so there's also a lot of the spelling looks a little bit different. There's two alternate spellings, and that's like kilometer would be METER is fine and maybe more common, but METRE is also acceptable as well, and you'll see that in the workbook here a lot. Okay, so example 1. Now, before we do these conversions, and like for example, 65 kilometers is how many meters, there's a couple different ways you could do this. The less mathy way is to do the metric staircase. Okay, so on your second page, or on page 78, I would like you to do this. I'm going to give myself a little bit of space. We're going to put a metric staircase right here, okay? Now the metric staircase starts like this. In the middle of a section of your page, if you want to do it at the top of the page, at the bottom, wherever you have space, or on a separate piece of paper would be good actually too. You guys have paper in your binders there? A separate piece of paper? Might be good to start on a separate piece of paper. But what I want you to do, in the middle of the kind of half a page or whatever you're going to make there, I want you to make just a little line like this. And this is the base unit. Okay, so we're just going to put base on there. And a base unit for length would be like meters. Okay, an M for meters, right? Let's think about meters, because that's the examples we've been given so far. So in the middle staircase, the middle stair is going to be base. Now the staircase goes down from left to right. So as we move down, we're going to make another stair here, and we're going to go down and another stair here, and we're going to go down and another stair here. So make 3 steps to the right of the base going down the stairs. And we're also going to go the other way to make 3 steps that would be to the left and above the base as well. All right. So I call this the metric staircase because it looks like a staircase, okay? You're walking down the stairs or you're walking up the stairs. Now, I'm going to put the prefixes there from the chart in the page before. I'm going to put those on the staircases. So this is going to be deci. This next one is going to be centi. And then milli. So the deci is a D as a symbol. The centi is C, and the milli is another little M. So if we have a, for example, decimeter, as on the other page, and I'll spell it the other way, that is a D is the deci part, and then the M is the meter part. Does that make sense? Okay? So these are prefixes. And the base unit here is special, because there's different base units we could use. What about a second as a unit of time? So like a millisecond, have you ever heard of a millisecond before? Yeah. That is 1,000th of a second. A millisecond. And its symbol would be ms, little ms. Okay, so let's go back the other way. So next here is deca, and there's two acceptable spellings with a C, D-E-C-A, and D-E-K-A is also acceptable. Remember, this is an international system. So globally, you know, the K sound is used by different letters, and it's used different places. Spellings are acceptable. So you don't have to write both of them down there, but you can. I'm going to just erase one of them just for this use on my staircase. But the next, and deca, that's actually D-A is the symbol, prefix there. Then we've got hecto, and that's an H, and kilo, and that's a lower. These are all lowercase, and that's a K. Okay, so there are units above kilo, for sure. Does anyone know of any units that would be larger than a kilo something? Okay, a mile, that's good. That is larger than a kilometer, that's right. But the mile is from the imperial system. It's not the metric system. So actually, you won't see a mile on the staircase or in any of these types of units. But you're right, that's bigger than a kilometer. Okay, so think about it this way. One single byte, B-Y-T-E, if we're talking about computer information, what would be a really large amount of bytes? A what byte? A gigabyte, yes. And also what? A megabyte, yes. So mega and giga would be units that would be even larger than a kilo, okay? So there's kilobytes, KB, right? Kilobytes. There's megabytes, gigabytes, terabytes even. So these are all metric prefixes. The megabyte is a million. Megabytes is a million bytes. A gigabyte is a billion bytes. A terabyte is a trillion bytes. Yeah. Okay. And then can you think of any units that would be smaller than a milli something, a millimeter? What would be smaller than that? Anybody? Think about technology. What's the new kind of frontier of technology? It's blank technology. Or blank tech. Anybody know? No. Have you ever heard of nanotechnology? Nanotechnology, that is technology that on a billionth of a unit scale. So it's really, really small. Nanotech. Right? Have you heard that? Okay. So micro is something like a micro something, micrometer, micro, and nano. Okay. There's also pico and femto and little ones down there, but we don't have to worry about those. Okay. So now that we've got the staircase, let me show you how to use the staircase. Okay, everyone listening? So if we have 65 kilometers, I want to know how many meters that is. Guess what? It's like this. You're starting at the kilo step, kilometers. And to get to the meters step, you have to go 1, 2, 3 steps down, because a meter is a base unit. So this is how the staircase helps us. The staircase and the number of stairs and the direction are the ways that you move the decimal place in the original number. So again, if we have 65 kilometers equals how many meters, what you do with the decimal place, and the decimal place would be right about here, right? It's right after the 5. So you would have to go move that decimal place to the right, 1, 2, 3 spaces. And so 65 actually becomes, you move the decimal place over and you fill that space with a 0, 1, 2, 3. So the answer is 65,000 meters. You can put a comma there if you want. You don't have to, because commas sometimes look like decimal places, so you don't have to do that. But that's how the staircase works. It's an easy way to do it. Now, can we make sense of this? Well, yeah, there's 1,000 meters in every single kilometer. 1,000. So if we have 65 kilometers, that's 65 times 1,000. And the times 1,000 is represented by 3 decimal places to the right. Okay, so 65,000 is going to be our answer there. Now you'll notice here in the solution that they do it the math way. This is the math way. They are multiplying by a conversion factor. And this would be very good for you to understand as well. The conversion factor is, so the first thing you look at is the units, kilometers on the top in the numerator and kilometers in the denominator. And then you write the conversion factor as a relationship between the unit that you're given and the unit that you want. So 1 kilometer goes on the bottom and 1,000 meters goes on top. When you multiply these two numbers, the kilometers cancel out, the units cancel out, and you're left with 65 times 1,000 meters. So that's another way of doing it, but that's kind of mathy, and it's called unit analysis, and sometimes students don't like that. So if you like this method, then this is what you want to look at. But I like the staircase method. It just makes it so simple. So let's try another one. 1,200 meters equals how many kilometers? Well, you might already have this in your mind, but let's use the staircase to help us. Okay, so this question is 1,200 meters equals how many kilometers? Now it's important to note where the decimal place is on this number. It's right there, isn't it? If it's not shown, it's understood to be at the very end of the number. So what are we going to do with that decimal place? Well, we're going to start on the staircase where this is. This is the base, right? Meters has no prefix in front of it, so it's the base. That's where we start. And where do we have to go to? Where do we have to go to?
Kilometers.
Yeah. And where is kilometers on this staircase? It's over here, isn't it?
Yeah.
Kilo, see? So guess what? I have to go 1 step, 2 steps, 3 steps to get to kilometers, from the base unit to kilo. And so that 3 steps up the staircase represents the decimal place moving 3 steps to the left. So this decimal place is going to go 1, 2, 3, and it's going to land right here. So we would write 1.2, and you don't have to write the zeros after. You can, but you don't have to. Okay, so that's 1.2 kilometers. Now that should make a lot of sense, because if there's 1,000 meters in every kilometer, 1,200 meters means 1.2 kilometers. Got it? Okay. 5 out of 5 here, understanding? 5 out of 5? Okay. Now let's do one more. Let's skip down to D. Excusez-moi. Let's take a look at D here. So 5,600 millimeters is how many hectometers? Ooh, that's a tough one. 5,600 millimeters is how many hectometers? Okay, milli to hecto. So in this case, what we do is we start at, where do we start here? This is the unit, or this is the number. So where am I starting? Which step am I starting on? At the milli step. Yep. And where am I going to? I'm going to this step right here, right? So it looks like I'm going to have to move that decimal place which direction? Left. And how many spaces? That's 1, 2, 3, 4, and 5. Does that make sense? So 5 spaces to the left. So let's see, 5,600, I got to go 1, 2, 3, 4. And if you have to go an extra space where there's nothing there, you fill in the space with a 0. So I'm going to put a 0 in front. I'm going to put that decimal. Then 0, 5, 6. And you can put 0, 0 if you want. You do not have to. The zeros at the end can be left off. How many of you understand this 5 out of 5? Okay. Anybody a little less? Okay, 4. Okay, okay, that's fine. All right. Well, let's do some questions then from scratch. Let's do a couple build your skills questions. So this conversion, centimeters to meters, I'm going to give you 1 minute to do this question using the staircase that you've drawn out there. So I'll give you a chance to do it, and then I'll show you the answer in a minute. Go ahead and try it. All right, so this is the answer that I got for A. You tell me if I'm right. Anybody else get that? Now let's just see. We started at centi, and we're going to M. That is the base, and it's just M by itself. So centi, going to the base, that is 2 decimal places to the left. So if the decimal starts here, I got to go 1, 2, 1.80 meters. You can leave the 0 on there if you want. At the end, you don't have to have it. Okay? All right. Millimeters to meters. Well, millimeters starts here, and I got to go 1, 2, 3 spaces to the left. So guess what? The decimal is understood to be after the number if it doesn't show up. Like there's a decimal place here in this one, but not in this one. So 3 spaces to the left. That's 76 meters. Okay? All right, so I'm going to leave C and D for you to do on your own. Let's take a look at number 2. And number 2 would be filling in this chart. So let's work with this now. So if we have, let's start with this second row. We have 325.5 millimeters. So 325.5. If I want to convert that to centimeters, which way do I have to move the decimal place? To the left. Very good. So millimeters, was it millimeters, right? To centimeters. I have to go 1 decimal place to the left. So this number now becomes, the decimal place is now there. So it's 32.55. Does everyone see that? Does that make sense? Yeah? Okay. Decimeter. So now we're going to decimeters, so we have to go 1 more space to the left. So 1 more space to the left puts the decimal place right there. That's 3.255. The meter is 1 more space to the left. So now I'm going to start to put a 0 in the front there. 0.3255, you see? So that decimal place gets moved over once every time. And of course, you can keep that pattern going. This is now 0.03255, and I'm running out of space. Another space, 0.03255. And 0.03255, okay? So, does everyone see that? Now let's take a look at that. 300 millimeters, okay, on this meter stick, 300 millimeters, that's not too very far down the meter stick here. You count 300, and it's 32.55 centimeters. So it's right about here. It's this length right here, right? So how much of a meter is that? Well, it's roughly 1/3 of the whole meter. It's roughly 1/3. So look at this, see, 0.3. And so on. So it makes sense that this number of millimeters is a smaller and smaller portion of a larger unit. So think about how many kilometers this is, right here. How many kilometers is this right here? A very, very small number of kilometers, right? Right? And of course it's 0.0003255 kilometers, like a super small number. Okay? Got it? Okay. So I'm going to give you just a few minutes to finish 1 and 2. So go ahead, finish 1 and 2, and then we'll move on. So here's some more answers for you just to see if you're doing this correctly. I didn't fill out all the answers for you because I want you to do that and submit that later. But here are some more answers just to see if you're on the right track. So you can take a moment to take a peek at that, and then we'll move on with the second review here. All right, so let's move on to the second part of review here, working with rounding. So often it's necessary to round measured values to show the level of accuracy of your measurements and calculations. Round each measurement to the indicated degree of precision. So precision means like how exact can you be? So if this says we need to round to the nearest tenth of a unit. So let me make this number just a little bit bigger for you, 87.253. So first of all, this is the tenth, right? This is the tenth. What's this one called? May I remember? What's after the tenth unit? Tenth. Is it? Are you just saying what your what someone else said? It is. It's the hundredth, tenth, hundredth. What's next? The next is the thousandth. Good. Okay. Okay. So let's just start with that. So if we're rounding to the nearest tenth, that means that we're going to write this number, and this number. But before you write this tenth, you have to round it. So that means you have to kind of like give me the approximate of this number. So what you do is you look at the number to the right of it, and that's the 5. So generally, if the number is 5 and greater, 5, 6, 7, 8, 9, then you have to round up. So this is a 5, so that means we write this number as 87.3. This one goes up because of the 5. And there's your answer. All right? 87.3, and millimeters, of course. Now this one right here, 3564 meters to the nearest 10. Well, this is, the first number is ones, the second number is tens, the third number is hundreds, the fourth number is thousands. Okay? So, to the nearest 10, so 35, that's all right down here, 3564. The nearest 10 would be this number right here, the tens spot. So should we round this number to 3570, or should we round it to 3560? That's the question. Which one is this one closer to? It's closest to this one. See that? Now if you look at what you do is in deciding what number this should be, you look to the number to the right of it. If the number is 0, 1, 2, 3, or 4, that is anything under 5, then you leave it as itself. You don't move it up. You never move it down. You would either leave it alone or bump it up 1. Okay? You guys get that? Any questions with that? Okay. So I'm just going to give you an example, one you don't have in your workbook, you don't have the answer to. So what about this one? 1, 2, 3, 5, 7, 9 to the nearest, nearest 1,000. To the nearest 1,000. Write down the number that would be rounded to the nearest 1,000. Go ahead and see if you can figure that out. I'm going to freeze the screen and I'll work it out in the background and I'll show you. So where is the thousands? Where's the thousands spot? And then how would you determine whether you leave that number alone or bump it up? So is this number closer to 123,000 or 124,000? That's what you're asking yourself. And of course, because this is 579, it's closer to 124,000. Yes? Question?
No.
Is that a hand up or
That's not that.
you were high-fiving? Okay. Everyone else get that? Let me know if you have any problems with that. Okay. So this one right here is some more practice with rounding. And let me just make this a bit bigger. Okay, so rounding, let's do a little bit of practice here. So rounding numbers to the nearest tenth of a unit, again, that is the first number after the decimal place. We look at the number to the right of it, and it's a 7. So guess what? This number in question, this 2, has to go up to a 3. And then you put zeros after that. That's the other thing we didn't mention, but we've been doing, is you bump this number up or you leave it the same, and then every other number that's shown you leave a 0. Okay, zeros. They have to be zeros. So 5, 6, 7.3. And you can leave it like that, or you can show zeros there if you wish. All right, B, again, nearest tenth of a unit. That's 6, 5 point, what am I going to write here? Is it 0.6 or 0.7? It's 7. And all the rest of the numbers after that are zeros. Good. You don't have to put the zeros, no. I mean, technically, this has 5 digits that are called significant digits, and you may have learned this in science class last year. And so this one should have 5 significant digits as well, but I'm not going to worry about that. If you write it just 65.7, I'm cool with that. But you do have to fill in the zeros like in our previous examples here, right? Like these ones here. So you can't just say this is 124 and I'm done. You have to have the zeros there. So it's a good idea to make all the other numbers that are shown into zeros. That's just safest usually. Okay. Okay, what about number 4? Round the following measurements to the nearest hundredth. So that's not the first number after the decimal place, that's the second number. This one is 92 point what? What do I write here?
7.
Nearest hundredth. Okay, 7. Anything else? Sorry?
If there are
9,
staff who have not had your
0.
picture yet, could you please
Yeah.
make your way down to
92.79.
Again, if
0.
there's any staff
So
who
this
have not
8,
had your picture
we have to
taken
look at
yet,
the number to
please
the
make
right,
your way to the gym
and if
foyer.
it's 5 or above, we bump the number up. Okay, what about number 5? I'm not going to do any more from that one, but number 5, the nearest whole unit. So that means the nearest kind of ones digit. Okay? So this is 0.786 kilometers. We need to round it to the nearest whole number, basically. So that's going to be, is that closer to 2987 or 2988? You bet. 2988. And that's because I looked at this 7 to the right of it, and it was greater than 5, so I bumped the first 7 up. Okay? And your units should put your units there too. So that's for letter A. Okay. All right, so take a few moments, a few minutes. I'll give you some time, maybe up to 5 minutes, and finish 3, 4, and 5. Got it? All right, go ahead. So there's a few selected answers for 3, 4, and 5 as well. And as I just mentioned, this one's a bit of a tricky one, D, because if you look at this number, is it closer to 0 or 1? And because this is so small, you look at the 0 and you look at the 0 to the right of it, and you'd have to keep it at 0. So it's closer to 0 whole units. All right. So we're almost done the lesson for today. We're going to work on one little small section here, and this is working with accuracy. So I want to talk to you about accuracy and the appropriateness of measurements and that sort of thing. So accuracy and precision. So here's the difference. Frozen, thank you. Page 81 in your workbook. So accuracy and precision. Here's the difference. Precision would be how exact is your measurement. That's what we've been working with in this last little bit, rounding it to the nearest whatever. So if I'm taking a measurement of the mass of this easy button right here, okay?
That was easy.
If I'm taking the mass of this and I say it is 1 pound, 1, you would say, okay, that might be close, but can't you be a little bit more exact on that? And the answer is yes, I can be more exact. I can actually be quite a bit more precise, which is being more exact. I could say this is actually 1.427 pounds. And that is, you see how that's very
Grade
precise?
10 homeroom teachers,
Right?
please make your way to the gym foyer. All
That
grade
was
10
easy.
students
That was
and
easy.
homeroom teachers
Okay.
to the
So-
gym foyer.
All right. So, accuracy, right on. The exactness of a measurement. Now, in example 3, we talk about an important way to look at how we're measuring things, and it talks about accuracy. So, explain, in example 3 says, explain if the following measurements would give an accurate measure, and if the measuring device is appropriate. So, two things. When taking measurements, it's important to think about the appropriateness of your unit. For example, you would not need to know the distance. You would not need to know the distance between cities in millimeters, right? That would be overkill. And it would be such a large number, it wouldn't really even help you. You would have to think about that a different way to make it make sense. So, example 3. So, if you are using the length of your forearm to measure the length of a picnic table, do you think that that would be a very accurate measurement when you're done? Okay, what would be the units of measure that you're using? Forearms, okay? So would your forearm be different than someone else's forearm probably? Okay, close, but very different, right? So if you measured the picnic table in forearms, that's not really an appropriate unit, right? And it wouldn't be very exact. It'd be like, well, forearms, I don't know, half, a three-quarters of a forearm, I don't know. And what does that even mean, right? So it wouldn't be very accurate, and it probably wouldn't be really appropriate. You'd be guessing. What about this? Using the length of your strides, that's one step, to mark off the playing field for soccer. Well, you could do that, but it would be a rough guess of the distance, right? You could think, oh, my step is about a yard. Oh, maybe it's a meter. Maybe it's somewhere in between. So it might be appropriate, but it wouldn't be very accurate. C, using a meter stick to calculate the distance between two cities. Well, you would get a very accurate number because the units are so small comparing to the distance. But would it be appropriate to do that? No. No. You'd have to use something larger like kilometers or miles or something like that. And then finally, using a ruler marked in millimeters to measure the width of a book. So the width of a book, right, if you used a ruler in millimeters, that would be very exact. And it would be very appropriate for this size. Not between one city and another city for millimeters, but the width of a book totally. Does that make sense, or do you have any questions about that? Okay. All right, so we have about 10 or 15 minutes left here. So let's take a look at the three... Oh, you don't have this page on it yet? Okay. Well, let's take a look at 6 together. Look up on the screen there. Okay, you were supposed to have that page, sorry. Number 6, build your skills. Would it be possible to accurately tell the time on a watch face that has no numbers? Why or why not? Use the following diagram to help explain your answer. So if you guys were just answering this, what would your answer be?
It depends how well you know.
Okay, it depends how well you know a clock.
Look at it and just like imagine the numbers.
Okay.
Like the clock.
Yeah, okay, depends how well you know a clock, okay. So what time is this exactly?
No.
7 o'clock. Okay. Clearly you need numbers. Okay, that is not 7 o'clock. 7 o'clock. Oh, that is hilarious. No, 9 is not straight down. No, 6
Yeah.
is straight down. Yeah, 6. 6 is straight down.
9 was at the bottom and 0 was at the
That would be
top.
like 4. That
Okay.
would be 420-ish, not 5.
Okay, so it'd be,
Closer to
oh,
5.
okay, so 4:20-ish. You'd say 5 something?
Oh, like this.
4:30.
Oh my bad.
Okay. Okay. So right away, we've got answers ranging from 7 to 5:30 to 4:20. So it's obviously not. You guys don't know how to tell time in analog clock. I can see. Okay. Well, is it 4:20 or 5:20? Do you think? What would it be closer to? What would this be closer to? Hey guys, would this be 4:20 or 5:20? Because I don't think anybody mentioned 5:20. There was a
I said
4:20.
520. I said 5:30-ish.
Okay, 5:30. Listen, 30. That the big hand would have to be straight down to the bottom. So it's definitely not 30, right?
Yeah.
But this proves the point that this is inaccurate, right? Inaccurate. And I can tell you stories. I had a watch like this once, and I was totally an hour off for something really important, and I chucked that watch away. Anyways, I thought it was cool, but yeah, it didn't know help me because I was the same way. I'm like, is that 420 or 520? And I looked at it and thought it was 420 when it was 520, and that was my story. So, in answering this question, would it be possible to accurately? Not very accurately. And plus, there's no second hand either. So if we're talking about accurate, why wouldn't we include seconds? Well, there's no second hand even, so you can't tell. You just have to guess. So in explaining this answer to this question, you would say probably not that accurate because there's no numbers, there's no second hand at all, and it would be easy to confuse the 4 and the 5 here, and so on. So, okay, so that would be what you'd probably say. All right. So what I'm going to get you guys to do is to look at, actually what I'll get you to do is to finish all of the Build Your Skills questions if you haven't done that yet from 1 to 5, and then I will get you this paper and you can finish the 6 to 8. Okay? And if you are done 1 to 5, you can answer on a separate piece of paper using the board.